Hey students, how are you doing? So we're supposed to have webinar online live today, but due to some technical issues, I couldn't make it. So I'm going to upload this video to the YouTube. There will be several videos to cover your seminar. But today, I'm going to discuss about the Part 1 booklet that you have downloaded. Part 2 booklet is there at madhisugan.com. Those who have not downloaded yet, you can go to this site and download it now. www.madhisugan.com/webinar. Visit this site and download your booklet now. You can continue after that. Before going to the booklet, I would suggest you some tips. You will waited very long time to attend this O-level examination, not only ICT, all other subjects. So you have studied all 9 subjects. You have waited for the exam scheduled for a long time. Now it has been scheduled and you have to write the exam by mid of May or end of May till June. So before you write the exam, I would like to suggest you some tips. This is not only for ICT, any subject you have to well prepare, and you have to well prepared with the theory first. Then you have to use, you have to do all the past papers. So this webinar covered all the syllabus that you have studied. Not only that, also some technical part, especially in ICT, that you can use. After you write your answer, or after you choose your answer from MCQ, first of all, you have to find out the answer that you have chosen is correct or wrong. You can decide. For that, you need a short time period to verify your answer immediately. So if you want to verify your answer, especially in number system, I will teach you the method. Within 5 to 10 seconds, you can do any type of number system question. Similarly, you also can verify your answers for the logic case question. So let's see how you can make it. For an example, if you get the question to convert binary to decimal, or binary to decimal, or decimal to binary. Binary to decimal, you know, this if there are numbers like this, you will be getting 4 answers down. Right? Carefully note down these tips. Any binary number you show like this, you should be able to get the quick answer, at least the very nearest answer for this. Example, if you get this same question, 10110 base 2 in decimal. Suppose if you get the answers like first answer is 21, second answer is 19, third answer is 23, and fourth answer is 22. I can directly answer the question. Answer is 22. I don't want to check any other method to do this. So how should I? First of all, I will teach you how to convert this binary into decimal. So converting binary into decimal, you 1, 0, 1, 1, 0. This is base 2 to the power of 0, that is 1. This is 2 to the power of 1, that is 2. This is 2 to the power of 2, that is 4. 2 to the power of 3, 8. 2 to the power of 4, 16. 16 into 1, 16. 8 into 0, 0. 4 into 1, 4. 2 into 1, 2. 1 into 0, 0. 16 plus 4, 20. 20 plus 2, 22. That is the answer. Okay, everybody, you know this is your answer. But by mistakenly, some students may do a mistake. If they calculated 16 plus 4 plus 2 plus 1 sometime, suppose if they put 1 by mistake here, they will choose the answer 23. So how can you verify your answer if you made a mistake on it at the examination? If you made a mistake at the exam, you can verify the answer like this. Very, very, very important step. This is not a very technical. This is not a rocket science. This is very, very easy. Carefully listen. Always, you know, this is the first bit we call MSB, most significant bit. The last one we call least significant bit, LSB. MSB and LSB. Always remember the MSB will decide the nearest answer for you. LSB will decide whether the answer is odd or even. If your LSB is 1, definitely you will end up with odd number. If the LSB is 0, definitely will end up with even number. So in this question, I checked only LSB, not MSB, because LSB is 0. So your answer must be even number. All the other answers are odd numbers. So I have chosen this number as a correct answer. So you can easily verify your answer using this method. Always remember, LSB will decide whether odd number or even number. MSB will decide the number that nearest value. Right. We'll do another example here. I'll take into another page. So let me write then another example 1, 0, 0, 1, 0, 0 is 2. Right, now the answers given here 35, number 2 is 36, answer number 3 is 64, answer number 4 is 82. Right, if you ask this question now you may have doubt. LSB is 0, so this is even number, but we have 3 even number answers. MSB is 1. MSB is always 1. Remember that MSB will be always 1, right? When you have a number systems in A-level section, there will be a number system will with 8 bits representation. Even though suppose the 8-bit representation, first two zeros can be ignored, the answer would be 1 base. Even if you have 0, 0, 1, 0, 0, 0, the MSB will be 1, not 0. Remember that. So MSB is 1, LSB 0. So LSB 0 means this answer could be an even number. So if this is an even number, how can you verify which answer will be the right answer? Because this is even, this is even, this is even. Right. For this, you have to use the MSB value. In this type of situation, you have to use the MSB value. What is the value of MSB? This is 1, this is 2, 4, 8, 16, 32. 1, 2, 4, 8, 16, 32. So this number, something nearest to 32, what would be the next number? 64. 32 after that, 64. And you can decide this number 100100 would be in between 32 and 64 even number. In between 32 and 64 even number. So in between 32 and 64 even number, only one answer we have. So this is the right answer. This is wrong, this is wrong, and this is wrong. If you practice like this, you will take only 1 to 10 seconds to answer this type of question. Okay, this is if you get the question from binary to decimal. Right, now you may ask, suppose if we get octal numbers or hexadecimal numbers, what will be the answer, solution? Even if you get the octal number or hexadecimal number, same thing. Suppose if you get the octal number like 6, 2, base 8, what is the value of this? This is 1, this is 8. 8 into 6, 48. So the MSB value is 48. And this is even number. LSB is even number. So answer would be even number. Right? Suppose if you get hexadecimal number A, B, C, base 16. 1, 16, 256. 256 into 10, 2560. So the number will be something nearest to 2560, something more than 2560, and this will be the odd number or even number, because 10 is A, 11 is B, 12 is C. This is even number. So definitely your answer would be an even number. Now, if you check the past paper questions, you can easily get the answers, because most of the past paper question you can answer in this way. Okay, this is all from binary to decimal conversion or any other values, octal or hexadecimal to decimal conversion. Okay, let's talk about how to convert the numbers from decimal to binary. This is also a very important part. When it's come to 40 decimal, if you want to convert 40 into binary, the usual method that you are using is 40 divided by 2 is 20, and remainder 0. 20 divided by 2 is 10, remainder 0. Divided by 2 is 5, remainder 0. Divided by 2 is 2, remainder 1. And when you divide this 2 by 2, answer is 1 and remainder 0. Don't forget this remainder 0. So your answer for 40 will be, you have to write from bottom to up. So 1 0 1 0 0 0 is 2. So this is the traditional method that you are following. I would suggest you an easy method for this is like this: 1 2. You know the placements. You know the placements of the number. Same like the number, have it for decimal numbers. If this is 10, hundreds, thousands, ones, tens, hundreds, thousands, like this. We have in binary number 1, 2, 4, 8, 16, 32, and 64. Let me take this one little. Right, so then it's easy to see. Right. How to convert this number 40 into binary, and before that, how to memorize this number. As you all know, most of the memory devices which are in GB, gigabyte, is 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, 32 GB. We don't have any 10 GB pen drive or 10 GB RAM. We don't have any 25 GB pen drive or 25 GB RAM. Right? All is either in 1, 2, 4, 8. Why I am saying is GB, because TB, when it's come to terabyte, we have 1 terabyte, 2 terabyte, 3 terabyte. Terabytes, we have options 1, 2, 3 series, 1, 2, 3, 4, 5, 6. We have in series, but when it's come to gigabyte, we have 1 GB, 2 GB, 4 GB, 8 GB, 16, 32, 64, memory card, pen drive, RAM, hard disk, SVD site like this. Right. Nowadays, you can't find the hard disk in GBs, all available in TB, but you can find the RAM, memory cards, and pen drive in this size. Right. You have to convert 40 into binary. If you want to convert 40 into binary, 40 will not come under with 64. That will come the 32. 32 is less than 40, and 40 is nearest to 32. So 32 is 1. 32 plus 8 is 40. So 8 is also 1. 32 plus 8 is 40. Now you find out 40. Rest of the number is 0. Very easy. Okay, let's practice in this some other numbers like 1. Let me write down this one different way. 2. So we can try many other numbers this way. Very short method. 1, 2, 4, 8, 16, 32, 64, and 128. Suppose if you want to find out the number 130, very easy. 128 plus 230, rest of the numbers are zeros. Very easy. Suppose if you want to find out number 30, very carefully listen this one. This one has another part. If you get the number 30, before I do the 30, I will do 33. The number 33 is very easy. 32 plus 133. 32 is 1. Rest of the other numbers are zeros. This is 33. This is 130. This is 33. Okay, let's go to 30. Number 30 or 31. Let's do 30. This is compared to 33 is 30 is little harder. So how can we, I will tell you how can we do that also. So after 32, 32 will not come under. So 30 is not covering by 32. It's covered by 16. After covered by 16, there are reminders 14. So that will be 8, 16 plus 8, 24, 24 plus 4, 28, 28 plus 2, 30, and 0. This one is little harder than previous two, right? This one is little harder than the previous numbers. So how to find out the easy number and the hardest number? Easy number should be little higher than these numbers. 1, 2, 4, 8, 16, 32, 64, 128. 130 is more than 128, so that is easy. 33 is little higher than 32, that is easy. If any numbers little less than these numbers are harder. So what is this less than this number? 30 is less than 32, so that is hardest one. 60, if you get 61 or something, that is hardest one. If you get 125 or something, that is also hardest one because that is less than 128. So any numbers little less than these numbers are hardest one according to this, and any numbers less than, greater than, or more than these numbers are easier one. Right? How can we convert these hardest numbers into easy method to convert again? So if there's a method is easy method, then definitely you should have the easy method for any type of numbers. So how can we decide this number is easy? Very carefully listen. If you get any number less than 32 or nearest to 32 and but greater than 16, you put like 1 after 32, all 1. So what will be this number? Can't see this properly, so I will change the color. What will be this number? All the numbers 1. So remember, if I hide this 2 and asking you to find out the number, like after this 2, 1, if you put 1, that is 1. After 4, if you put 1, 1, that is 3. After 8, if you put 1, 1, 1, that is 7. So if you put all the ones after 32, that's equal to 31. If you put all the ones after 64, that's equals to 63. And remember, after 64, if you put all ones, this is equals to 63. Still, I didn't get the answer. Hold on. Let me write this, the next one as well. After 128, if you put all the ones, after 100, don't put 1 for 128. After 128, if you put 1 for all these numbers, that is 127. So I'll come back to this 30. I have to find out 30, but I have wrote here is 31. How can you convert 31 into 30? From 31, you have to subtract 1 from 30. You have to subtract 1 from 31. So 31, if you put all the ones, that is 31. 31 minus 1 is 30. So this is 30. So now you have find 63 here, but you need a 61. How can you make 63 to 61? You have to subtract 2 from that. It's easy. Again, you need 125, but you found is 127 here. 127 minus 2 is 125. Hope you understand this. If you couldn't understand, you can rewind this one. How to convert decimal numbers into binary quickly. So converting these number systems will help you to get the quick answers for your exams. So don't forget to practice this before you go for the exam. This will definitely help you. So only decimal numbers into binary have this G.C.E method. The rest of the method you can use like decimal numbers into octal, decimal numbers into hexadecimal. You can use as usual. Decimal number converting into octal number, because when you convert any large decimal number like 80 base 10 into octal, 80 you have to divide by 8. 80 divided by 8, 10, and 0 remainder. 10 divided by 8, 1 time, 2 remainder. Within 2-3 steps you will get the answer, right? 80 base 10 equals to 120 base 8. Within 2-3 steps you will get the answer. But binary, to get the answer you have to spend more than 3-4 steps if that is larger number. If it is 80, you have to get another steps also. If it is 130, you will take more time to divide by 2 and find the answer. But this step, you can directly find the answer, 128 plus 230. And you can revise the previous one I told. If the numbers end with 0, that is even number. Yes, 130 is an even number. 33 is odd number. Yes, this end up with 1 is odd number. 30 is even number. 61 is odd number. 125 is odd number. So these are the LSB, least significant bit. This is MSB for this. This is MSB for this. This is MSB for this. Like MSB values will vary, but MSB value will decide what's the number and what's the number range that you need. Hope you understand about this number system. I will meet you with another video for the logic kits and the rest of the seminar part. Thank you.